The title of the presentation is Earth-Shaking Revelations Toward Incontrovertible Seismic Evidence of Pre-Impact Explosions. So the word toward is important because this is a research project that is in progress. And as I said, we are trying to complete this study by the end of the year. And it's a collaboration between myself and geophysicist André Rousseau. André has 2 degrees that are equivalent of PhDs in earth sciences at universities in France. He is a researcher, or was a researcher at the National Center of Scientific Research from 1972 to 2007. He published more than 60 peer-reviewed papers, and he published one very important paper in the 9/11 literature called "Were Explosives the Source of the Seismic Signals Emitted from New York on September 11, 2001? By the way, if you can't hear me that well, just raise your hands and I'll try to adjust. You can't hear that well? It's not good. Is this better? Oh, yeah, I also don't want to go too high. Okay, all right. Just raise your hand if you can hear, because I want you to hear everything. Okay, so the research question that we've been tackling is, did the seismic activity at the World Trade Center on 9/11 precede, 1, the airplane impacts, and 2, the impact of debris with the ground during the collapses of each tower? And if we can determine this conclusively, well, then we have incontrovertible evidence of explosions at the World Trade Center. Now, there's a lot of aspects of the seismic evidence of the seismic activity that was created on 9/11 that points to the use of explosives. We're not going to, a lot of it's more qualitative, the types of waves that were emitted. We're just going to focus on the timing, though. If you want to learn about that other stuff, check out Andre's paper that I mentioned before. Okay, so there's going to be 3 parts to this presentation. Eyewitness reports of explosions prior to plane impact and earth shaking prior to debris impact during the collapses. The second section is timing discrepancies between the visual data and NIST's revision of seismic event origin times to fit the visual data. Third, we're going to look at 3 reasons why the revised origin times are wrong. So part 1, eyewitness reports of explosions prior to plane impact and earth shaking prior to debris impact. So this is janitor William Rodriguez, perhaps the most well-known 9/11 witness, giving an interview on the day of 9/11, where he described what he experienced as not like an impact, like a rumble.
Well, which of the 2 buildings were you in?
I work on building 1, the one that got hit the first time.
Tell me what happened.
I was on the basement, which is a support floor for the maintenance company, and we hear like a big rumble, not like an impact, like a rumble, like something like moving furniture on a massive way, and all of a sudden we hear another rumble, and a guy comes running into our office, and all his skin was off his body.
Okay. Another video of William speaking a few years later. He's kind of clarified the story of what he witnessed in his mind. Let's hear what he has to say. He says, 2 different events separated by almost 7 seconds.
So I was talking to the supervisor, and at 8:46 we hear boom! An explosion so hard that pushes us upwards in the air, upwards. And it came out from below us, from the mechanical room that was right below us. And it was so loud and so powerful that all the walls cracked, the false ceiling fell on top of us, the sprinkler system got activated, and everybody started screaming so loud because they didn't know what was going on. 6 to 7 seconds after, we hear, bah! The impact all the way on the top of the building of the plane. 2 different events separated by almost 7 seconds.
Okay. Next, I'm going to play a speech or a talk by this man, Anthony Saltalamacchia, was William Rodriguez's supervisor on the day of 9/11. And we're just wondering how much what he witnessed corroborates what William Rodriguez witnessed.
That's when, you know, we heard just a loud explosion, like massive explosion. It just knocked us just like off our feet. It was just like unbelievable. Right when that happened, I was like, that's a bomb. I was like, what the hell was that? So we were like trying to figure out what was going on. When that happened, then another explosion happened, and it was just like boom, like, you know, I'm just like, wow, what's going on? Like, again, we got like knocked away, and like, what's going on here? You know, and it literally sounded like it was just like, not particularly like a grenade, like people setting off grenades, but it was like, picture like just like multiple grenades just going off, just like bam, bam, boom. And, you know, that's what I thought. I was like, is there somebody in here like blowing up the place? It's like, you know, it was wild, you know?
So just a quick comment on the similarities and minor differences between what they've described. William is very clear in his account that the sound that he heard 7 seconds later was coming from the top of the building, that he thinks it was the impact of the airplane. Whereas Anthony says it felt more like another explosion. So we don't necessarily know, but what I want to say is I think it's important to note that the first thing that both of them experienced was something under their feet, something powerful, something that caused the ceiling tiles to crack. It wasn't that the first thing they heard was the sound way up on the top of the building, or it wasn't if they heard a sound on the top of the building and then jet fuel poured down, 90 stories and just caused this explosion. It was the very first event that happened that caused the damage and the sensations that they felt. All right. If anybody can help me figure out who this guy is, let me know, because I would like to talk to him.
I think a bomb went off in the lobby first, then a plane hit the building, but then another plane hit the other building. But when I was coming through the doors on the other side of the Trade Center, either they blew the lobby up or something, because it blew the glass out of the doors and knocked us all down, and I got smoke and everything on me. I just feel a little shook up because I got blasted,
Okay, so he's describing an explosion in the lobby before either plane impact. All right, I'm just going to go ahead and play this, and what we're interested in here is corroborating whether or not there are two events.
We're sitting in the ballroom of the World Trade Center Marriott Hotel, listening to a presentation on the future of financial services, when we felt the floor shake. Felt like a minor earthquake tremor, sort of thing I felt in Vancouver a few months ago. And then sort of a second shaking, and the chandeliers started to rattle overhead, and that was the point when everybody decided it was probably a good time to leave.
Good time to leave. Okay, Jane King, reporter reporting on Fox 5 News in Washington, D.C. She described a rumble about 5 seconds long preceding the actual collapse. So we're moving now from the airplane impacts to the collapses. And when do people start to feel the ground shake?
When the buildings collapsed, we could hear a rumble, which was about 5 seconds long, preceding the actual collapse, and then a boom when each of those towers collapsed.
Okay, 5 second long rumble and then a boom. All right, so we have a few, Graham McQueen, late Graham McQueen, the film Peace War 9/11, his final interview. He published a paper in 2009 called "Did the Earth Shake Before the South Tower Hit the Ground?" which I think is an exceptional paper that I strongly recommend. And in that paper, part of what he does is identify 17 reports of ground shaking prior to debris impact by members of the FDNY and the Port Authority Police Department. So a few of those that I think are most compelling: Jody Bell, FDNY. You hear this rumble, everything is shaking. You hear this thunder, this rumbling. Then you see the building start to come down. Alexander Lutsky, FDNY. I heard a rumble, almost like an earthquake. Then I started to run for safety too, because I looked up and I saw that the building was going to come down. Bradley Mann, FDNY, this is perhaps the most clear and specific. Shortly before the first tower came down, I remember feeling the ground shaking. I heard a terrible noise, and then debris just started flying everywhere. Similarly, for the second tower, the ground shook again, and we heard another terrible noise, and the next thing we knew, the second tower was coming down. Okay, so these eyewitness reports are suggestive of explosions preceding both the impact of the planes and the shaking of the ground. Did the seismic evidence, the seismic activity that was recorded on 9/11 corroborate what these witnesses experienced? And so this is timing discrepancies between the visual data, meaning the cameras and showing the plane impact, and the collapses when they started, and the seismic data. And then NIST's revision of seismic event origin times to fit the visual data. So Columbia University's Lamont-Doherty Earth Observatory based in Palisades. If you look at where it says PAL there in the white circle, the closest to the World Trade Center, that's their headquarters. They operated 34 seismic stations in the Mid-Atlantic and New England. Many stations picked up the seismic signals that were created on 9/11, but there were 6 in the immediate New York metropolitan area that did. And we're going to be focusing on 5 of those 6. Lamont-Doherty was later contracted by NIST in 2004 and 2005 and actually wrote what became Appendix B of the World Trade Center 7 report, which was published in 2008. So the first thing to understand here is the way that what Lamont-Doherty did was basically they were able to establish the origin times of these seismic events, because when a seismic event happens, it basically transmits waves in all directions. And if the terrain is roughly similar, as you see here with all these seismic stations, it is going to reach those seismic stations in a pretty orderly way, where if it's traveling at 2 kilometers per second, you can, the timing of these stations, you can essentially line them up according to their distance from the World Trade Center, and sort of, except for one that is faster, and that's Manny on the right-hand side of the Hudson River in red, but the rest are on the west side of the Hudson River. And when you look at the arrival times, it all kind of lines up. And so if you draw basically a regression line of their arrivals, it goes all the way back to, in the case of the North Tower, 10/28/31. Essentially, these waves were traveling at 2 kilometers per second, and it took them 17 seconds to reach the first seismic station, Palisades. And here, so in that paper that they published in 2001, just hands up if you can't hear me well. Okay. And in the FEMA report in 2002, they published these seismic event times, again, the origin times. We're using the arrival times to determine the origin times. The origin times are an estimate. So NIST begins their investigation. In case anybody doesn't know, this is the National Institute of Standards and Technology. NIST begins their investigation in 2002, and one of the first things that they do is they start compiling a large database of all of the video footage that they've collected from, many sources, and they start trying to put that together in a timeline so that they can understand how the fires traveled through the building and supposedly led to the collapse of the towers. And so they got this huge database, and they're able to locate all these events relative to each other, but they have to figure out what time they actually occurred. And so they actually use the impact of the second plane as the reference time or the anchor time. And they use Lamont-Doherty's time, and I have it circled in. So what we have here on the left is the video evidence, which NIST analyzed, and the seismic evidence on the right, which Lamont-Doherty analyzed. And NIST bases the entire timeline on the idea that there was, that the impact of the second plane took place at 9:02:54, because that's when the seismic activity originated. But as they start to look at the footage more, as they look at the footage more, they actually realize that the time in blue, 9:02:59, is when the airplane actually hit the South Tower. And so that's 5 seconds, a whole 5 seconds later than the seismic activity. And so they kind of scratch their heads. And the first thing that they do is they move the times based on the video footage. They move the entire timeline forward 5 seconds. And when they do this, actually, I want to note that, first of all, they're doing this based on TV network footage, and that has timestamps on it, so it's pretty reliable. And also, when they moved it, the collapse of WTC2 starts at 9:58:59. That's the third row in purple. That's what we're looking at. And that actually matches up perfectly with my colleague Graham McQueen's analysis of when that tower started to collapse. So I think, and others who've studied this think, that those times in purple are pretty accurate, with the exception of the first one. I won't get into that, but there's essentially no video evidence of the first one. We don't have that. They just made that up. I won't get into trying to explain it. Oh, I'm looking at a different screen than the one on the big screens. Do we know why that is? Okay. Oh, no, that's not it. Oh boy. All right. I'll go based on this then. All right, so they move those times forward, but obviously we have a big problem here. The impact time is 5 seconds later than the seismic time for the second plane impact, which is actually a long time. That does not make sense. And also when we look at, and so I put question marks around the ones in yellow because those are the seismic times that don't make sense. Also, we have only essentially 5 seconds. When you look at the collapse of WTC2 in the third row, we have only 5 seconds for the start of the collapse to supposedly the debris hitting the ground. And I think we all know that wouldn't be enough time. And I want to emphasize that NIST said, this is what NIST and Lamont-Doherty, this is written by Lamont-Doherty, so this is the experts. They say a seismic signal is not generated until a substantial portion of the debris hits the ground. So what do? NIST goes back to Lamont-Doherty and says, can you take another look at all this? It doesn't make sense. We think maybe you got your estimates wrong. And Lamont-Doherty comes back to NIST, and this is in the fall of 2003, and says, yeah, you know what? We got it wrong. Actually, all of the origin times were 3 seconds later, all right? And so now the purple row and the green row, they kind of match up, right? At least they're within the combined uncertainties, all right? And so the big question here, and now I want to say one thing about the collapse of WTC2 in the third row here. When you compare the purple and the green, now they're 8 seconds apart, and they say that 9:59:07 is when the seismic activity started. Graham McQueen carefully studied the video footage and showed that actually the debris did not hit the ground until 9:59:11. So that's still 4 seconds too early, but we're going to put that aside for now. So the big question here. Okay, I want to this is the only explanation that they gave in 2005 when they published these revised times in the final report on the Twin Towers. These signals have subsequently been reanalyzed by Lamont-Doherty, working under a contract from the NIST World Trade Center investigation. A reinterpretation of the types of seismic signals received resulted in slightly revised times for the major events. So that's all they told us. Fast forward to 2008, they released the report on Building 7, and there's an appendix, which was essentially the report that Lamont-Doherty had prepared in 2005. And finally, we get the rationale for moving the origin times. The original origin times were estimated from Palisades records, assuming that large amplitude arrivals corresponded to signals that had traveled with a speed of 2 kilometers per second. So there's that magic number again, 2 kilometers per second. In the fall of 2003, origin times of the first 4 events were slightly revised based upon re-examination of the seismic data. Continuing along here, there was a seismic arrival about 4 seconds, so another wave that arrived 4 seconds earlier prior to the surface wave, which is the waves we've been mainly looking at, from the collapse of WTC2. This seismic arrival was identified as an S wave with a speed of about 3.4 kilometers per second. So this is a much faster type of wave. The travel time of the S wave was 10 seconds as opposed to 17 seconds, which moved the origin time to 3 seconds later than the initial determination. So the way that I like to represent what they did here, if you look at the top bracket where it says original origin in red all the way to the RG wave arrival, that's 17 seconds, okay? And it's from 0 to 17. And then what they essentially did was if you move down to the second bracket, they discovered this other wave, this S wave that arrived 4 seconds earlier. And they said that wave took 10 seconds to travel to Palisades. And so actually the origin time of the seismic event is 3 seconds later. And so that's their revised origin. But what this also means is that they got the speed, the velocity of the Rayleigh wave, that was the basis of their estimate, they got that wrong. Those waves were actually traveling at 2.4 kilometers per second. That's a very big difference. 2 and 2.4 kilometers is quite a difference and quite a lot for them to get wrong. The question here is that revised origin time 3 seconds later accurate? Or is it actually the original origin time 3 seconds earlier? And I just restating that question. Got 13 minutes, okay. So part 3 reasons the revised origin times are wrong. So this is what I've been studying with André Rousseau for the past several months. trying to figure it out. So first we had to go and get all the data, and there's a way to download data from basically any time you can download, and there's all different types of seismometers at all these different stations for all 4 events. So we have dozens and dozens of these seismograms. This is just giving you a little snapshot. Second plane impact and the WTC2 collapse. I'm going to give you maybe a 1-minute crash course on the 4 different types of seismic waves, because they're actually all relevant to this puzzle. So the P wave is a deep wave. It's a body wave that travels the fastest of the 4 types of waves, and it moves in like a rug pulling back and forth. It moves in the direction of that the wave is traveling in. I'm not going to get into how they're created, but you need a very powerful event at the surface of the Earth to actually create a P wave. Very, very powerful. S wave is the second fastest. That's also a body wave traveling deeper in the Earth. It's much slower than the P wave, but it's still faster than the other 2 waves. And that moves both basically perpendicular to the direction of the wave. So the wave is going in one direction, and the S wave is going left and right and up and down. The Rayleigh wave, which is the wave that we look at the most when it comes to like short distance kind of events like collapses or explosions or whatever, that one is actually the slowest wave. And that one moves in a sort of cyclical way. So what you get is that forward, backward motion and up, down, and no horizontal motion. And then the last wave, it's faster than the Rayleigh wave, but it's called a Love wave. And Love and Rayleigh are both named after real people who actually predicted these waves before they were discovered. And the Love wave, it's sideways, and it's, again, faster than the Rayleigh wave, but slower than the S wave. And it's only perpendicular to the direction of the wave. Okay, so these are the actual seismograms that NIST and Lamont-Doherty referred to when they, as the basis, this S wave that arrived earlier. So when you see the biggest squiggles, that's the Rayleigh wave, that's the main wave that arrived. But they said 4 seconds earlier, another wave arrived. So that's what we have in the squares, is this other wave that they say is an S wave. And if you look at the top, I'm telling you right now that the answer is the Love wave. It is actually a Love wave, not an S wave, okay? So you can basically look at the nature of these waves. These are the 3 different components. One is north-south, one is east-west, and the last one is up and down. The Z is up and down. And so you can look at these 3 different waves, and you can actually turn the data in them in such a way, the horizontal data, so the first 2 that I showed you, these data, you can turn the data so that the north-south and east-west is actually in the exact direction of the wave. And when we look at that white line from World Trade Center to PAL, that's the direction of Palisades, that's the direction of the wave. And from that, you can actually determine how much of this energy is side to side and how much of it is longitudinal or radial in the direction of the wave. And what we see here is that most of the energy, far more energy, is side to side. And that basically tells us that this is a Love wave. We can also deduce that it's a Love wave because it's so close to the Rayleigh waves, and an S wave typically would show up a little earlier. And also just S waves have a much smaller amplitude, and these have a higher amplitude. So this is basically incontrovertible, and that's what we're trying to figure out is how incontrovertible is it? We think it's pretty incontrovertible that this is a Love wave. And the reason why that's important is because the S wave travels faster, the Love wave travels slower. And so if you actually accept that arrival at 13 seconds is a Love wave, it actually matches up perfectly with the original origin time. It would take that wave 13 seconds to get to Palisades. So the reality here is that NIST and Lamont-Doherty misidentified that as an S wave so that they could claim a later origin time. And then they basically said, we'll just assume that the Rayleigh waves actually traveled faster. They had some wiggle room with the Rayleigh waves, but they didn't have any wiggle room with the Love wave. So they called it an S wave. Okay, the other reason why this revision doesn't make sense is there was a P wave that was created during the collapse of World Trade Center 1. Again, I said a P wave is requires a lot of impact in the ground. And it's pretty unlikely that the debris falling into World Trade Center would create P waves. The existence of a P wave itself is very indicative of an explosion, of a subterranean explosion. Nevertheless, just reminding you that the origin time for the the North Tower collapse, it's circled there in the bottom right, was moved from 1028.31 to 1028.34. And so this P wave, which André identified in his paper back in 2012, this P wave arrived around 1028.36. This was the data that he had available at the time. Now, 1028.36 is actually not very much time after 1028.34. In fact, it's a very small amount of time. And when we use the more precise data that we downloaded, we see that the arrival was probably around more like 1028.35.6. So supposedly this wave traveled 34 kilometers in 1.6 seconds, if we are to believe that the origin time is 1028.34. That would mean a speed of 21 kilometers per second, which is impossible. Okay, so, and we know that's a P wave because of the squealiness, the nature of it. And as you can see to the left of it, there's nothing going on. There's no disturbance until 1028.35.6. So we know it's a P wave, and we know that that P wave could not have come from an event that occurred at 1028.34. It had to be 1028.31, and the speed of 7.4 kilometers per second actually makes perfect sense for a P wave. The last reason is that when we move the origin time of all the events, we get sort of out of whack, unrealistic Rayleigh speeds. Again, Rayleigh are the slowest ones. Those are the ones that Lamont-Doherty used to generate their estimate. And we get a nice clean regression line of 2 kilometers per second when we assume 1028.31. Now, here's another way to depict that. These are the four stations on the western side of the west side of the Hudson. And if you look on the far right of the table, the speed is sort of clustered around like, 1.8 to 1.95, 1.98 kilometers per second. And they're all kind of bunched together on that graph. As soon as you move the time 3 seconds later, you actually get a much faster slope for the Rayleigh wave that was received at Palisades. And it's much faster than the others. Just because it's closer and you move the starting point, it really affects the slope. And you're alleging that this wave traveled really fast compared to the other waves. So just go back and forth there again. Everything kind of fits together there. You move it forward, and that wave is moving a lot faster, supposedly. And Lamont-Doherty never suggested that the speeds to the various stations would vary that much. To the contrary, for example, they said this in Appendix B of the 2008 World Trade Center 7 report. Seismic surface waves, mainly of the Rayleigh type, travel at about 2.4 kilometers per second between the World Trade Center site and stations in the region. So they're generalizing that speed to all of the stations. And the surface waves arrive first at Palisades, followed by the other stations. So there's no reason to think that it should travel that much faster to one station. Maybe a tiny bit, but not that much. We also actually have empirical evidence from the 1970s where they detonated explosions at quarries just north of Palisades. So those two yellow dots circled in yellow are quarries north of Palisades near the Hudson River. 5 minutes? All right. And the data shows that those waves traveled between 1.5 and 1.8 kilometers per second. And I put a little arrow there to point out the gray area where the waves are that Palisades is located on. That's a different type of terrain that's a little more igneous rock as opposed to sedentary. But nonetheless, even though these waves are traveling through mostly igneous rock, they're still less than 2 kilometers per second. Okay, and if you keep that gray sliver in mind here, what I'm going to show you next, it's going to turn pink in the next. That pink sliver is that same sliver of igneous rock, basically along the edge of the Hudson, on the west side of the Hudson. And we can basically look at the path from World Trade Center site to Palisades and see that, well, some of it's on Manhattan, with what's called the Manhattan Prong, which it might travel a little bit faster. Some of it's on the Hudson River, where it's actually going to travel slower. And most of it's still on the Palisades sill, which is that pink area. So really, there's no reason to expect that this path would somehow, substantially increase the velocity of the wave and we get up to 2.4 kilometers per second. We really should be looking at something around 2 kilometers. So, and when you accept that it's 2 kilometers per second, it fits all the data. All right, so ultimately, how did NIST and Lamont-Doherty falsify their analysis? They wrongly identified a love wave as an S wave. They ignored or downplayed the presence of a P wave. For example, they say seismic records from the 5 major World Trade Center events show no clear P or S waves, even though it's there in the records. And they inflated and distorted the velocity of the Rayleigh waves. So it's like a puzzle, but it all fits together perfectly when you go with their original times. So what we have here is that all the data fits together when we accept the original times. And essentially, the two columns in purple and yellow are accurate. The columns in purple and pink and green are not accurate. And we have a big problem. The seismic activity is preceding the plane impact and is preceding the debris hitting the ground during the collapses. So I want to actually answer one question. First of all, I want to point out that the eyewitness accounts were all related to the first plane impact. Unfortunately, we don't have video evidence of the first plane impact of the time that it occurred. But we have very good video evidence of the second plane impact and of the seismic activity. And so we can deduce that what those witnesses witnessed for the first plane impact, perhaps it's plausible that it happened with the second plane impact, and the seismic evidence proves it. Secondly, when you look at, you might be wondering, why does, for the second tower, so the third row, why does the collapse of WTC2, why does it take 5 seconds? Why does it start at 9:58:59 and the seismic activity started at 9:59:04? I thought they were talking about the shaking starting earlier than the collapse. Why is it 5 seconds later? So Graham McQueen, in his paper that I recommend highly, basically looked at the movement of a camera near the World Trade Center as it started to come down. And he actually measured the shaking of this camera. And what he found was that the camera started to shake 3 seconds before the start of the collapse, consistent with what the eyewitnesses reported, right? And then the collapse starts, and then at 9:59:04, which is I've circled, the shaking gets bigger. And so when that shaking gets bigger at 9:59:04 is when that seismic activity, that seismic wave was generated that was strong enough to travel 34 kilometers and beyond. And then lastly, the debris actually hits the ground at 9:59:11. And Graham studied this frame by frame, the soonest debris to hit the ground. So that's probably what really happened. Graham already figured it out for us in 2012. So that's it. I just want to thank the people that helped with this study, that are still helping. Sandra Laratonda for French-English interpretation, because André speaks English, I speak French, but it's easier when Sandra's there. So Michael Cobbs, who did the seismogram visualizations, and my colleague, Dr. Pierce Robinson, for his feedback and input. And lastly, in memory of the late Dr. Graham McQueen. So thank you.